When Chris first contacted me about coming to CCI to do a treatment on this very rare piece of 18th century textile, I was quite enthusiastic. The textile in its original state is not able to be exhibited because of the stain, and it's very disfiguring and it's distracting from the viewer. Most textiles cannot be subjected to stain reduction treatment, but this particular textile is unique in that it is, first of all, white. If it has color or embroidery, then it would not be suitable for stain reduction treatment that we had planned for. And also, it is very robust. If it was fragile or brittle in any way, we would not be considering the treatment that we had planned. Based on initial images, we thought that the stain contained iron because it was kind of orange. So we had planned that if it was iron, then we would need to use a combination of dithionite and EDTA solution in order to reduce and remove the iron ions. Further stain removal would require the use of sodium borohydride. Borohydride has many benefits. As a reducing agent, it is able to reduce the discoloration and also reverses some of the effects of aging. And also it is alkaline, and it would be able to reduce the acidity of the textile, as most historic textiles are acidic. In addition to Chris's extensive experience in textiles, we also need a team of conservators and scientists at CCI in order for this treatment to be carried out successfully. As a scientist, I have the knowledge on research and also experience on using these chemicals and their effect on textiles. But in addition, we need the textile conservators in the textile lab, Renee Doncos, Janet Wagner, and our intern, Michelle Hunter. They are all knowledgeable and experienced with treating and handling historic textiles, and they know and very familiar with large textiles and their own vulnerabilities. Our paper conservator, Crystal Maitland, is experienced in using treatments for stain reduction on paper, but she is also experienced in using gels to further remove stains. When we first saw the textile, we were quite surprised as to how much worse it looked in real life than from the photos. So we got together and we did spot testing of the stained areas, and it was quite alarming. The pH of the darkly stained areas, some were as low as pH 3, which means that it is extremely acidic. If left untreated, those areas with time is going to deteriorate and become brittle, and it will destroy the textile in the long run. The X-ray fluorescence analysis showed us that the area that is heavily stained contains iron, but so does the rest of the piece of textile. It has a low level of iron all across the piece of textile. Because the stained area does not have a higher concentration of iron, we felt that the stain is not caused by iron. Our spot tests also show that by adding a small amount of detergent in the water, the stain becomes soluble much faster and much more readily. As a result of these spot testing and the analysis, we planned the following course of treatment. First, we will use a low concentration of an anionic detergent, Orvis in this case, 0.1%, and we're going to immerse it and remove as much as the surface dirt and as much as the soluble discolored material as possible with the detergent wash. We rinse it as many times as we need to remove the detergent residues. And then following that, we're going to try to use gellan gum to see if we could further reduce the staining. After that, we will use dithionite in combination with EDTA to remove any harmful metal ions that is in the textile, and followed by rinsing. The final step, if we need to, we will use the sodium borohydride to remove the remaining stain to brighten the textile. The heavily stained area, we're going to use a higher concentration of sodium borohydride solution in order to reduce the stain as much as possible.
Before the wet cleaning of the petticoat, a few preparations needed to be undertaken. The first step was to stabilize some of the loose elements to protect them during wet cleaning. The petticoat has 2 vertical pocket slits and an unfinished waist edge. To protect these areas, we placed a sheer polyester fabric over them and temporarily stitched them into place using polyester threads. The next step was to mechanically remove the accretions and loose particulate soiling on the surface of the textile. The accretions were gently removed using tweezers under microscopy. The loose particulate soiling was removed by gently vacuuming the textile using low suction. To assist with wet cleaning treatment, we used a conservation-grade surfactant. This surfactant was prepared by dissolving it in water and stirring it to ensure it was fully dissolved.
The petticoat is quite large, and so we assembled a large stainless steel wash tank for the wet cleaning treatment. So it enables us to wet clean a petticoat in about an inch of water. We don't want to use any more water than is necessary. The petticoat will lay flat in the wash tank. We also have assembled a small plastic wash bin, and that will be used in the fume hood because it's necessary for the sodium dithionite treatment, which is quite smelly, and a smaller wash tank or wash tub was necessary to use in the fume hood.
We just completed the first step in the wet cleaning process. We filled the tank with the reverse osmosis water from the textile lab supply, and in the end we filled the tank with about an inch of water, which is about 90 liters of water, and that was enough to cover the textile while it was in the wash tank. We then added the prepared surfactant into the wash bath, into those 90 liters of water, and we just evenly distributed the surfactant in the bath just using our hands. Due to the size and weight of the petticoat, we had to pre-fold it, and we placed it on the nylon screen. So we placed the screen with the petticoat on top into the wash tank, and then we unfolded the screen in the wash tank, which filled the whole wash tank, and then we slowly unfolded the petticoat. We then wet out our natural sponges, and we gently sponged the petticoat to loosen the dirt, focusing on the stained areas. So we did that, several people did that, and we gently sponged for a number of minutes. We then floated the textile in the water to turn it over so that we could gently sponge the other side. We took samples of the water at this point just to determine what the discoloration was and how much dirt was coming out of the textile, and if indeed another wash bath was warranted. And it was determined that it was not, that the discoloration was not that much, and we would not do another bath with surfactant. So then at that point then we floated the textile again in the bath, and we folded it into a smaller area, and so that it can be removed from the wash tank, and the screen was also folded so it could be lifted out with two people out of the wash tank onto a supporting table. We then emptied the tank with the aid of the portable pumps, and we also had to tilt the table at some point to get more water out, and also use squeegees to get the water out so that we could prepare the tank for the rinse.
After the surfactant bath, the petticoat was rinsed a number of times in reverse osmosis water until all the surfactant has been rinsed out.
So as a final stage of washing, we moved the textile out of the baths and onto a table, blotting it dry with toweling to damp dry. And then we tried gellan gum for the highly stained areas of the textile. Gellan gum is a high molecular weight polysaccharide. It's a natural biopolymer that gels at really low concentrations in water. And it's used in conservation to deliver aqueous chemistry to the surface of artifacts. It helps control the spread of moisture or can increase the dwell time on a surface. And it also has a small amount of capillary pull that can help pull degradation products or soiling off of the surface or out of objects. Low acyl gellan gum has been explored extensively for paper conservation, and it's a relatively transparent, rigid gel that is surface conformable enough for a paper and ink surface. But textiles are inherently more three-dimensional on a micro scale, from the twist of the thread to the weave of a fabric, to, in the case of this textile, the dimensionality of the embroidery. We needed a more conformal gel. Fortunately, there's a second type of gellan gum called high acyl gellan gum. It's much more drapable and unfortunately is not transparent. It's, however, harder to prepare at higher concentrations. And so by mixing the two, low acyl and high acyl polymers, we can get aspects of each: the transparency and easy preparation of the low acyl gel and the surface conformability of the high acyl gel. To make the gels, you have to heat a solution to a molten state. We use a microwave. And then to set the gels, you just pour them out into a container of your choice and let them cool. Formulations are a balancing act. We want a higher concentration to have smaller pores and more capillary pull, but we want the drapability that we get at a lower concentration. So by adding in high acyl, we get the drape with a higher concentration that we can pull from the low acyl gel. We left the gels in contact with the surface of the textile for about an hour. And in this case, we didn't see a lot of pull of discoloration products into the gel. We did achieve good surface conformability that we were looking for, and we'll continue to investigate the use of these gels in future conservation treatments.
After the application of gellan gum, we used two reducing agents separately, sodium dithionite and sodium borohydride. We choose these reagents because not only are they able to reduce stains, they are also not damaging to the textile. In fact, they have a stabilizing effect on the textile. We use sodium dithionite with EDTA to remove any harmful metal ions that are in the textile. And because the reagent is very smelly, we used it in the fume hood. We immersed the textile in 2% dithionite EDTA bath for about 30 minutes. The textile looked brighter as a result of it. The dark stains were slightly reduced, but they were still very prominent. After rinsing in reverse osmosis water, we decided that we need to immerse the textile in the sodium borohydride bath. So we immersed it in a low concentration of sodium borohydride for 30 minutes. There were a lot of bubbles formed from the textiles because of the hydrogen gas produced as borohydride react with the acids in the textile. After 30 minutes of immersion in the low concentration borohydride solution, we remove the textile and place it in the wash tank, and we apply a higher concentration of borohydride locally in the darkly stained areas. We also covered it with mylar so that it would prolong the effect of the reagent. After we felt that there's no more improvement of the color reduction, we ended the treatment and we immersed the textile in reverse osmosis water and to rinse out all the residue of the borohydride. After the treatment, the level of acidity has been much reduced. Harmful metal ions and oxidized products have been removed. The textile is much more stable from a chemical point of view. From an aesthetic point of view, the heavily stained area have been much reduced, and the lighter water stains have been mostly reduced. The overall appearance of the petticoat is much brighter. The delicate and refined needleworks with our subtle but elaborate pattern is now visible without distraction.
So the petticoat was blotted with many clean white towels in order to damp dry it. And the thing to remember about wet cleaned textiles is that we like to dry them fairly quickly. And this textile is very particular in that it's 2 layers, and each of the layers is composed of 3 layers of textiles. So we needed to create air circulation in order to speed the drying process. The textile was placed on a raised support screen, and it was raised by using blocks to allow air to circulate underneath the screen and around the petticoat. We separated the 2 layers of the petticoat in order to provide more air circulation, and we did this by bunching up some nylon tulle fabric inside the petticoat. Next, we used some very large floor fans to direct some airflow around the petticoat, and we also used handheld dryers on cool settings just to accelerate the drying process. It took over an hour of concerted effort with the handheld dryers on a cool setting to dry the petticoat partially. We will leave the petticoat to dry in the open air in the lab overnight.